Hi, Assalamualaikum and good day. Today you are going to learn the third power series, which is known as binomial series. This is the objective of today's lesson. Hopefully, by the end of this session, you are able to explain the function of a plus b to the power of n for a large number of n using the binomial series, where the straightforward multiplication wouldn't be easy to do it. Before we discuss further on the binomial series, let's do some recap on Taylor series and Maclaurin series first. For Taylor series, there are two formulas to be used. The first formula is known as Taylor series about the point x equal to a, in which the function fx is equal to fa plus f prime a multiplied with x minus a plus f double prime a over 2 factorial multiplied with x minus a square plus so on. The second formula is known as Taylor series in power of x, in which the function fx plus a is equal to fa plus f prime a multiplied with x plus f double prime a over 2 factorial multiplied with x squared plus so on. By putting a equal to 0 in the Taylor series, we obtain the Maclaurin series, which is represented as fx equal to f0 plus f prime 0 multiplied with x plus f double prime 0 over 2 factorial multiplied with x squared plus f triple prime 0 over 3 factorial multiplied with x cubed plus so on. Maclaurin series is a special case of Taylor's series. If you recall, binomial series refers to the Maclaurin series of the function 1 plus x to the power of n. Generally, binomial series for the function a plus b to the power of n, where n is a positive power, is represented as follows. A plus b to the power of n is equal to the sum of ni multiplied with a to the power of n minus I multiplied with b to the power of I for I equal to 0 until n. Ni is the binomial coefficient, which is expressed by the formula n multiplied with n minus 1 multiplied with n minus 2 multiplied with so on until n minus I plus 1 over I factorial, which can also be represented as nci. The value for ni or nci can be obtained using the calculator. When the binomial series of a plus b to the power of n is expanded, you will notice that the expansion has a pattern, which is known as a Pascal triangle. Take a look of the expansion when the value of n range from 0 to 4. The two outside edges of the triangle are comprised of value 1. The other terms inside are the sum of the two terms immediately above them in the triangle. The triangle can grow as many rows as you desire. Refer to example 6. You need to use the binomial theorem to explain the function of 2x minus 3 to the power of 4. Before finding the expansion, first you need to identify a, b, and n. In this example, a is equal to 2x, b equal to negative 3, and n equal to 4. Substitute these values into the binomial formula accordingly, you will obtain the following expansion. Take note that the number of the terms is 5. Which is greater 1 than the given power. You may also use the symbol for Ci in your expansion. Up to you which symbol you want to use, either using the bracket or using C. Next, simplify each term carefully. You will obtain 16x to the power of 4 minus 96x to the power of 3 plus 216x to the power of 2 minus 216x plus 81 as the final answer. Please watch out the signs. When you are asked to find only one term in a binomial expansion, there is no need for you to explain the whole expansion. For example, if you need to find the r term of the given function a plus b to the power of n, you need to know that the coefficient of this term will be ncr minus 1, where the power of b is r minus 1 and the power of a is n minus the power of b. Putting this information together gives us a formula for finding the r term of a binomial expansion, which is n r minus 1 multiplied with a to the power of n minus in bracket r minus 1 multiplied with b to the power of r minus 1. Refer to example 7. You need to determine the fifth term of the expansion of 3x minus 4 to the power of 12. For this example, a equal to 3x, b equal to negative 4, n equal to 12, and r equal to 5. Substitute these values accordingly into the formula and simplify. You will obtain 831409920 to the power of 8 as the fifth term of the expansion. If given the function of a plus b to the power of n, where the power of n is the range of 0 and 1, you need to apply the following binomial series. 1 plus x to the power of n is equal to the sum of ni multiplied with x to the power of I for I equal to 0 until infinity, which is equal to 1 plus nx plus n multiplied with n minus 1 over 2 factorial multiplied with x squared plus n multiplied with n minus 1 multiplied with n minus 2 over 3 factorial multiplied with x to the power of 3 plus so on. Take note that before you can apply the formula, you need to represent the function in the form of 1 plus x to the power of n. Refer to example 8. You need to determine the first 4 terms of binomial expansion for the function square root of 9 minus x. Before finding the expansion, first you need to rewrite the function in the form required, that is 1 plus x to the power of n. Then identify the values for the new x and n. In order to obtain 1, you need to factorize the 9. You will obtain the square root of 9 multiplied with 1 minus x over 9, which can be represented as 3 multiplied with 1 minus x over 9 to the power of 1 over 2. Here, the new x is equal to negative x over 9 and n equal to 1 over 2. Substitute these values accordingly into the formula and simplify. You will obtain 3 minus x over 6 minus x to the power of 2 over 216 minus x to the power of 3 over 3888 minus so on as the first 4 terms of the binomial expansion for the given function. Refer to example 9. You need to find the first 4 terms of the binomial series for the function square root of 1 minus 3x and hence estimate the value of the square root of 0.97 correct to 4 decimal places. For this example, the function is already in the form of 1 plus x to the power of n, where the new x equal to negative 3x and k, which is also referred to n, equal to 1 over 2. Substitute these values accordingly into the given formula and simplify, you will obtain 1 minus 3 over 2x minus 9 over 8x squared minus 27 over 16 x to the power of 3 plus so on as the first four terms of the binomial expansion for the given function. Next, to estimate the value of square root 0.97 using the expansion of square root of 1 minus 3x, you need to determine the value of x first. You will obtain x equal to 0.01. Replace all x inside the expansion with the value of 0.01 and simplify, you will obtain 0.9849 as the answer for the square root of 0.97. To check your understanding on the binomial series, please do the following question.